Hello everyone, I am Amanpreet. I am a research engineer at Facebook AI Research, and today I'm going to talk about TextVQA, dataset, baseline, and challenge. This is a joint work with Rongang, Devi, and Marcus at Facebook AI Research. So let's talk about today's agenda. First, we are going to talk about TextVQA dataset and what exactly it entails. Then we are going to talk about this year's baselines, LoRa and emphasis specifically. Then we will discuss the challenge winners, and finally we will do some analysis on the challenge. Let's talk about the TextVQA dataset first. TextVQA dataset was introduced in CVPR last year and contains questions on images which require reading text in the images to answer those. For example, if you see a top left note of image, you can see the question, what does the word on his face say? The answer is posterity, but to not answer playable, you need to understand where the face is and how it's linked with posterity. Similar things can be seen in the other examples in this image. Let's talk about the statistics of the TextVQA dataset. On the right, I will show some examples from TextVQA dataset so you get an idea of how the TextVQA dataset works. The number of images inside TextVQA dataset are 28,000. While the number of images with text are 100% through the virtue of how we constructed TextVQA dataset, while the questions inside TextVQA dataset are 45,000. The number of questions which have an answer inside OCR token are 39%. The OCR tokens are from Rosetta, which is state-of-the-art OCR system from Facebook AI Research, and images are from OpenImages. The state-of-the-art VQA models don't really work on TextVQA as they can't read and reason about the text in the images. So the VQA challenge winners from 2018 only achieved 12 or 13% accuracy compared to human accuracy of 35% on this dataset. This is not good as many applications of VQA require reading text in the images. So let's discuss some challenges which make this dataset very difficult. So first of all, this dataset needs open-ended vocabulary. For example, time can be anything. You can't really hard-code it inside vocabulary. You need to pick up the OCR token and directly put it. Then there are multi-word predictions. You need to link different OCR tokens to answer some questions. For example, if you want to answer who wrote this book, you need to understand which words join together as the name. Then text detection is also a problem. The text detection algorithms are not perfect at this point, and sometimes the text detector is wrong, as shown in this example. Even if you detect text extraction is a problem. For example, in this rotated text, even though the text is detected, the extracted text is wrong. Then this also involves reasoning as a normal VQA problem. For example, if you have to answer how many coins are there, you need to understand how many each coin is and then combine them together to answer 100. This also involves world knowledge. For example, you need to figure out what the brand name is. Last year, we introduced LoRa as a baseline, which uses fast text for OCR features and combines them with image and text features to Fusion module and uses a pointer network to point to the OCR tokens as the answer, which can be dynamic. This achieved a test accuracy of 27.63%. After last year's TextVQA challenge, we at Facebook AI Research with some collaborators worked on pushing forward the state-of-the-art on TextVQA challenge. We introduced a transformer-based model which projects all of the embeddings into a common space and also can do multi-word predictions using a generator head. This pushed the text accuracy by 40.46% by just the virtue of a better model and better projection schemes, and also multi-word prediction. So emphasis is accepted at CVPR 2020, and this is a joint work with Rongang, Trevor, and Marcus. So code is available inside our framework MMF, and you can join the oral talk at 9:25 a.m. on Thursday, June 18, and the post number 30. So let's see what exactly the solution each of the baselines provide for the different challenges inside TextVQA. So open-ended vocabulary, LoRa has dynamic OCR-based answer space and fast text embedding, but same emphasis uses same solution as LoRa but has more OCR embeddings, which lets it better model the OCRs. The multi-word prediction, emphasis has a generator pointer plus transformer network, while LoRa doesn't have that. Text detection, we still use same Rosetta model from Facebook AI Research, but we have a better version in emphasis. Reasoning is same like VQA model, but in LoRa it's Pythia based, while in VQA model in emphasis is transformer. For world knowledge, we rely on the priors of the data. Let's dive into the TextVQA challenge and see what exactly we got this year and do some analysis on it. First, I would like to thank Evaluate folks for their constant and rapid support in hosting this challenge. The starter code was provided inside our framework MMF for M4C model. This MMF contains sort of pre-trained models, dataset, and a lot of other things. For more details, visit mf.sh or see my other talk on VQA and Dialog workshops webpage. We welcome contribution and you can contribute your challenge-winning models to MMF for wider community reception. This year, 19 teams participated in the TextVQA challenge, and each team was allowed 5 test submissions. We received 350 plus submissions on validation phase, and we received 49 submissions on test phase. Thanks to Google Cloud, we are giving $10K GCP credits to the winner. Samples were not allowed this year, and we plan to continue disallowing samples in future challenges. An extra page was provided for submissions which violate challenge rules, including in samples and other things. Let's talk about the winners of this year's challenge. Congrats to joint team between Northwestern Polytechnical University and University of Adelaide on winning the TextVQA challenge. They achieved a test accuracy of 45.51. The second position goes to CVMLP team from Georgia Tech Facebook AI Research and University of Illinois, which received 44.80 test accuracy. Third place goes to Collab BU AA team from Bihang University, which achieved 44.73 test accuracy. I once again congratulate all of the winners and runner-ups, and I thank all of the participants to TextVQA challenge. Before we jump into this year's challenge and its analysis, let's have a look at last year's test accuracies. Last year's winner was able to achieve 31.44% on TextVQA, while this year's baseline M4C, for which we released starter code as well, was at 40.46% accuracy. A lot of teams this year beat M4C as a baseline and were able to push the accuracy till 45.51 using various techniques. This is an absolute 14% increase compared to last year, which is huge for TextVQA. So let's do some analysis on the submissions provided in TextVQA. Let's summarize the submission based on the abstracts we received. The winner team used graph attention on objects and text graphs, used a better OCR system, used extra OCR embeddings, and answer module. VQA team used OCR augmentation and focused on the OCR side mainly. CVMLB did better image features, used Google's OCR system, did better modeling of spatial arrays. All of these models added additional transform layers for better performance. Teams are generally performing better on multiple predictions after the introduction of M. Let's do some analysis on the TextVQA challenge submissions. This plot shows when the answer is in OCR tokens, how many times the submission gets it correct. So M4C has a huge number, but the winner team doesn't improve as much. And the teams with better OCR system are generally doing better on this. When the answer is multi-word, we see that the performance has improved a lot from last year. When the answer is never seen during training that the answer is zero shot, we see that we have seen a huge improvement from last year to this year, and compared to M4C, this year's submissions are performing better. We also check the number of unique answers predicted by a submission to see whether predicting more unique answers lead to better performance. We see that BU AA team has more unique answers compared to the winner team, which means that always predicting more answers doesn't mean that you will get better accuracy. Your system also needs to model it. Here are some takeaways from this year's challenge. Relationship modeling between entities is a very important aspect. OCR system is an important aspect and can't be overlooked. Having better OCR mostly leads to better performance. The scope in improving image features, which when improved always lead to better performance. Multi-word answer decoding always helps. Also, like adding more transformer layers help. Thank you for listening to my talk, and I hope that you got to learn something new about TextVQA. You can explore TextVQA at textvqa.org and mmf at mmf.sh. I once again repeat that we are open to community contribution and we look forward to see your models inside MMF. Thank you.